Hello everyone, welcome back to the channel. Today we are going over another example on how to draw shear force and bending moment diagrams. So without further ado, let's just get started. So here we see a simply supported beam with just a moment applied at the center of the beam. Alright, so when you're not familiar with these problems yet, all you need to remember is the positive sign convention, right? Which states that if you're looking at a beam and you're cutting it on the right side, the moment would be the counterclockwise moment plus the downwards shear would be positive. And if you're looking at it from the other side, which is the left side, it would be a clockwise shear moment that is positive plus an upwards shear, right? So this is the positive sign convention. So keep this in mind, it'll make drawing these a lot easier. Okay, so the next thing to think about is, okay, what are my reactions here? Alright, so in order to see my reactions, all we need to do is sum of moments around, let's say A, right, equals 0. Okay, so we have Cy and then times 2L, which wants to spin it counterclockwise, which is positive, minus MB, which is clockwise, and then that equals to 0, right? So then to solve for Cy, we simply move MB over, and then 2L to the bottom, that equals Cy. And then we can just do a simple sum of forces in the y direction to find that AY plus CY equals 0. So AY would just equal MB over 2L. Alright? So once we kind of got that figured out, right? And we can label that down. So CY equals negative MB over positive MB over 2L, and AY is actually going this way, and it is also MB over 2L. Okay, I know it's negative, but I just switched the direction in the graph. Okay, so once we have that, we can just simply draw the shear force diagram. All right, so in the last video, we explained that basically the concept is that if you took a cut anywhere along the beam, right, what sort of forces would be needed to kind of balance the system, right? So in this case, let's say we take a cut somewhere between 0 and L, right? And then we have AY over here, right? Which equals to MB over 2L, right? Let's say we have that. So what would be needed to balance this entire thing, right? We can just do a simple sum of forces. We find that shear is going upwards, right, of the same thing, right, MB over 2L. You have this going downwards and this going upwards, so it cancels out, right? And it makes the system balanced. So in this case, but since shear is defined as being positive in the downward direction, this upward shear would actually be a negative on the graph. All right, negative on graph. Okay, so we can say that it goes down by it goes down by MB over 2L, right, and stays the same because there are no external forces applied from 0 to L, right? How about from L to 2L? What do you think? Well, it would be exactly the same thing, right? Because there's no up and down forces applied anywhere throughout this beam, right? So we can just simply keep it as is, right? And finally, when we reach Cy, we can add that back, and that would just go back to 0. Okay? Simple enough. So the next thing I would advise you to do is, instead of doing moments or anything and just breaking the system up, chopping it, you can definitely think about it like that, but I advise you just take the area under this curve. Okay, so this area, as you can see, is negative mb over 2l times l, right? L's cancel out, and then that equals negative mb. Okay, and since it's we're dealing with a straight line, we can just go negative mb over 2, right? So once we get to this point, there's a question I would like to ask you, right? So let's say you just took this beam, right, and you cut it right after, like infinitely close, so close to B, but like right after this point, okay? So you have your AY going down here, and you have a clockwise moment being applied at B, all right? Now you're essentially cutting it at B, but infinitely to the right, okay? So this force would be included, right? Now my question is to you, what sort of moment would you need here to balance it? Did you think of something? Okay. Well, you need simply MB, right? Because if you take a moment about A, right, you use this as a hinge, you're spinning the whole thing clockwise, right, with MB. So in order to make it not, rotate into space, you would need a counterclockwise moment, right? And that's your MB, right? And since positive sign convention states that counterclockwise is positive when you're looking from the right, when you're cutting this like so, according to the diagram, it's just positive, right? So at this point, at this very point, we add MB, right? So MB minus MB over 2 is just, well, equal to MB over 2, right? Positive. So this point would be MB over 2, right? Now, how about this segment, right? It's the same thing, right? From L to 2L, right, you would still have negative MB over L, right? And then since MB over 2, this is MB over 2 minus MB over 2 is just 0, we can just simply draw a straight line here. And it's decreasing because this area is negative, okay? So keep that in mind. This is a negative area, this is also a negative area, right? So then that would equal to 0. And these would just essentially be your shear force and bending moment diagrams, okay? So that's really it for this problem. Now that I'm looking at it, my notes are quite messy, but in summary, what you need to keep in mind for these problems is just this sign convention and just follow it. Whenever you're not sure about which direction is what, just cut the beam. Cut the beam at which point you're investigating, all right? I like to just leave the beam to the right, to the left of things and cut like this, but you can definitely do it the other way around. Maybe something like that, right? But then your sign convention would be like this instead, okay? So it works both ways, but you just have to be a bit extra careful when you're going in reverse, all right? Now, that's really it. And just a reminder here, maybe this moment does not affect shear force, okay? Shear force is basically the sum of forces, and bending is the sum of moments, okay? So that's really it for this video. So I hope this helped, and I'll see you next video. All right, goodbye.